Hello viewers, welcome back. In our today's video, we will learn to calculate the value of short circuit current contributed by industrial generator in case of a fault in the power network. It is important to mention that this calculation provides the base for the selection of power network design. Whenever the fault occurs in the system, electrical components connected to the system will start to contribute towards the fault point. Today, we are only looking at the contribution from the generator side. To calculate the generator's contribution, we need some parameters which can be found in the generator's technical datasheet. The technical values in the datasheet varies from manufacturer to manufacturer, and it is important for the system designer to have the datasheet of the generator which is going to install in the system. Most important parameters to calculate the short circuit contribution are the rated current and the subtransient reactance of the generator, as the fault current is simply rated current divided by the subtransient reactance. If the rated current is not available, then we will need parameters like rated power, rated voltage, and the rated power factor. An example of generator technical datasheet is shown here. Required parameters for our calculation are highlighted. Now we proceed towards the calculation. In the first scenario, we have the rated current of the generator from the technical datasheet, which is 806 amperes. We simply divide the rated current with subtransient reactance of 16.3% and get the generator short circuit contribution, which is 4945 amperes. In the second scenario, we assume that we do not have the value of rated current, but rated apparent power in volts ampere and rated voltage is available to us. First, we calculate the rated current using the common formula, and then the short circuit contribution is again simply the ratio of current and subtransient reactance. In the third scenario, we will calculate the rated current from rated real power in watts. Therefore, we also need the value of rated power factor. Again, first we will calculate the rated current and then the short circuit contribution of the generator. It is very important to note that the value of short circuit contribution from generator is largely dependent on the value of subtransient reactance. The value of subtransient reactance largely varies from manufacturer to manufacturer. Usually it is in the range of 9% to 18%. Large value of subtransient reactance is difficult to achieve, and generators with high value of subtransient reactance generates lesser value of short circuit currents. Therefore, before starting the short circuit calculations, please check with your manufacturer actual value of subtransient reactance that will be delivered. In the last part of our video, we will try to relate the numerical calculations we have learned with the theoretical concepts. When a fault occurs in the system and we look at the waveform, we will find four important components across the current and time axes. First is the DC component or DC offset, which is the natural occurring phenomena due to the inception of fault at particular time interval. DC component dies out after few cycles and its value largely depends on the value of inductance and resistance ratio in the circuit. Since generators have high value of inductance, therefore if the fault occurs near the generator, then DC component will have high value. Second is the symmetrical component. As name indicates, the waveform is symmetrical around the time axis and is without the DC component. Third is the asymmetrical component, which is simply the sum of DC component and symmetrical component. Fourth is the peak value of asymmetrical component and is the value at the first half cycle. This is the most destructive force which system needs to bear. We can say that whenever short circuit occurs, first system will experience the mechanical impact due to the asymmetrical peak, and later the system will experience the thermal impact. So this is the end of our today's video. I hope it will help you to develop the understanding about the topic. If you like the video, please hit the like button. Please give suggestions for improvement in the comments box. Please also let me know if you need information about any other topic. I will try to cover it in my next vlogs. Please subscribe our channel and hit the bell icon so that you will get updates about the latest videos. Thank you.